Hey guys, we're back. Fred here at Math and Engineering. In the last video, we talked about the rules about sketching and transforming functions. So taking an original function and making different modifications to it based on constants that are being applied to that function, okay? Whether they're outside the argument, inside the argument of the function. So we're gonna do two examples. This one, which was actually a midterm question that was given to us when we did Calculus 1 in university. And so, this is perfect practice. This is something that could definitely come up for you. And we'll do one more, maybe a little bit trickier than this, but I think after these two videos, you watch both of them, you do them by yourself. If you want to pause at each step and kind of try it on your own, that would be a good idea. But by the time you're done these two videos, you should have a good grasp of this. So let's get started. We'll do it step by step. So this question here is going to have 5 steps, all right? And we're going to do each one with each modification to the function, just so you can see exactly what's happening, okay? So let's go ahead, we'll read the question, and then we'll start. Starting with the graph of sine x. Graph f of x equals 1 minus 2 sine x over 2, all right? Show all steps. Well, the first thing that we want to do if we see a question like this is we want to graph the initial function. Okay, so we want to graph sine x in our first step, and we want to work from there. So I think we all know what sine x is, right? If we don't, no problem. You're going to learn right now. So sine x, okay, I'm going to use green here for so we can see it better. Sine x starts from the origin, okay, and then it goes up, and then it passes through pi, and then it goes back down, and then it passes through pi over 2 on the right side of the x-axis, okay? And then on the left side of the the left side of the y-axis, it does essentially the same thing, okay? Just opposite, all right? And what's important here is we need to know what the range of sine is, okay? And we need to go ahead and show that. Okay, so I'll go ahead and just draw a line here. Okay, so the range of sine is on the y-axis from 1 to -1, or of sine x. So that's important to know. I'll just draw them over here too. So all right, that is y equals sine x. Very good. Okay, so that's step 1 done. We've drawn y equals sine x. Okay, so which transformation are we going to apply next? Well, I mean, you could do 2 sine x, but personally I think that if we apply the x over 2, that might be the easiest way. So let's go ahead and we'll try that. So the next one is going to be y equals sine x over 2. So if you want to go to the last video that we did, it had a list of all the rules. And if you want to just keep it open in another window and watch while we're doing this, if you'll see, if we have an x over 2, okay, so if we have a f of x over 2 where the x over c is inside the argument of the function, what's going to happen is you'll see the graph is going to be stretched along the x-axis, okay? It's going to be stretched out and it's going to be longer, okay? The periods are going to be longer. So if c is equal to 2 here, okay, what's going to happen is it's going to stretch horizontally by a factor of 2. All right, so the periods are going to be twice as long, okay? Which means that each period of the sine graph is going to take, instead of from 0 to 2 pi, okay, it's going to be from 0 to 4 pi, all right? So in this graph here, really that's, you don't have to go to 4 pi or 8 pi, just -2 pi to 2 pi so the professor knows that you know what you're doing. So if the period of this function is doubled, that means that this positive part of the sine graph will pass through 2 pi on its way down instead of pi, right? Because the period is doubled. So let's go ahead and write that. Okay, so there we are. Okay, so as you can see, we've stretched the function out there, but the range has remained the same. We haven't changed the range. All we've done is change the period length on the x-axis. And, I know this seems tedious. We have to write out the y values every time, but it's important to indicate that so we get full marks, all right? Okay, so that's done. We're done step 2. Let's move on to step 3, all right? And now let's apply that 2 there, okay? Let's apply that that constant, so we have c of f of x, okay? And if we remember, what's going to happen now is, remember, when we applied this x over c, or x over 2, all right, the period was increased by a factor of 2, okay? So now, in this part, since we have the constant out front, all right, and we know that that's going to affect the range, or the vertical stretch, the vertical range is going to be increased by a factor of 2. Okay, so instead of 1 to -1, it's going to go from 2 to -2. All right, that's important to remember. So our period length is the same. Okay, from pi. Okay, one period is going to be from 0 to 4 pi. Still, that's not going to change. But all we're going to do is stretch the graph and its range. So we're going to continue to start from the origin. Okay. And our graph is going to go up a little bit higher now. Perfect. Okay. And as we did before, and I'm just going to do this by hand now. Okay. We have to indicate that this is now 2. Okay. This is y equals 2. And this is y equals -2. All right. So and let me just draw the function, or write the function out. So we have 2 sine x over 2. Okay, so we're almost done. And well, what's left? As you can see here, okay, we have a negative sign in front of the 2 sine of x over 2, all right? And if we remember back from the video previously, go ahead and take a look. What that means is that we're going to have to flip the function on the y-axis. So let's go ahead and just do that. That one's self-explanatory, okay? All right, so imagine that the y-axis is a mirror, and we're just going to mirror it, all right? So we have 2, -2, and this is going to be y equals -2 sine x over 2. Perfect. And we're almost done. We just need to apply this 1 here, okay? And that's something that we didn't go over in the last video, and we'll just go over it right now, okay? And what that 1 is going to do is it's going to shift the function on the y-axis, okay? I think you'll remember that if you remember the equation of the line, y equals mx plus b. Essentially, this is our b, okay? So this is going to change our y-intercept. And all that means is that if we have a 1 here, okay, like this, let me just write out the function. So this is our final function, 1 minus 2 sine x over 2. All right, that's going to shift our function up the y-axis 1. All right, so our y-intercept is going to start at 1 right here. Okay, and our range is still going to be, all right, our range is still going to be 4, right? But because we're starting from 1, so from 2 to -2, we're starting from 1, that's going to go from 3 to -1. So that's important to remember. Don't make a mistake there. Okay, so we've drawn that, and now it's important to remember, guys, okay, is that the graph, or the sine graph, is not intersecting -2 pi and 2 pi anymore, okay? Because as it's shifted up now, but the period is still the same, all right, it's going to be a little bit past -2 pi and a little bit before 2 pi. And that's not that important, okay? It's not important where the x-intercepts, because honestly, you can't really get that precise when we're sketching by hand. The most important part is that you get the range correct. Okay, so that's supposed to be 3. This is supposed to be -1. Okay, 3, -1. All right, on the y-axis, and that's it. All right, that's the function. And it's important also to note that this is at -pi, and this is pi. Okay. So that's all. That's all it is, guys. It's not too hard. All you have to do is kind of do it step by step. Go through each modification of the function step by step and draw it out using the rules that we did in the last video. And you should be good after that. Just practice this one, practice some more. We'll do one more after this. Thanks for watching.